Welcome to Bytes. This is another video of Golang in which we are learning about the interface. These are the things we clear in this video. Introduction of interface. Interface are a powerful and fundamental concept. An interface defines a set of methods, but does not the implementation of those functions. It's also known as contract between client and developer. Developer have a job to implement those functions written in interface. Benefits of interface. Decoupling code. Interfaces help in decoupling code from specific implementations. By programming to an interface rather than a concrete type, you can change the underlying implementation without changing the code that uses the interface. This is incredibly useful in large code bases for maintaining and updating code easily. Enabling polymorphism. Go does not support classical inheritance, but interfaces provide a way to achieve polymorphism. Different types can implement the same interface and can then be used interchangeably depending on the behavior defined by the interface. This allows for writing functions and methods that can operate on any type that implements a given interface. Testing and mocking. Interfaces are immensely useful in testing, especially when it comes to mocking. By creating interfaces, you can mock dependencies during testing by using mock objects that implement the same interface. This helps in writing unit tests that are independent of external resources or complex dependencies. Encouraging good design. The use of interfaces encourages developers to think in terms of high-level policies and behaviors rather than specific implementations. This approach can lead to a cleaner, more abstract design, which often results in more maintainable and scalable code. Standard library integration. Many standard library packages in Go use interfaces. For example, the IO.reader and IO.writer interfaces are widely used to handle input-output operations, allowing the same functions to work with network connections, files, buffers, etc. How interface helpful for developer abstraction? Interfaces allow developers to work at a higher level of abstraction. By defining an interface, you specify the behavior you expect from any type that implements the interface without needing to concern yourself with the specific details of how each behavior is implemented. This abstraction enables developers to focus on the broader design and architecture of a system rather than the specifics of individual components. Decoupling. Interfaces help decouple the components of a program. Since an interface separates the declaration of methods from their implementation, changes to the implementation of a class that implements an interface do not affect the classes that depend on it, as long as the interface itself remains unchanged. This decoupling allows for easier maintenance and enhancement of applications without risking side effects to other parts of the system. Flexibility and scalability. Interfaces make the software more flexible and scalable. Because they allow any type to be replaced with any other type that implements the same interface, it's easier to add new types that can interact with existing code without any changes to that code. This flexibility is especially valuable in large projects and systems that need to evolve over time or incorporate new features. Testability. Interfaces improve testability. In unit testing, interfaces are essential for mocking and stubbing complex dependencies. Developers can create mock objects that implement the interfaces of components they wish to isolate from the unit tests, ensuring that tests are not affected by external dependencies or unpredictable behaviors. Code reuse. By defining generic interfaces, developers can write functions and methods that are widely applicable across different types, reducing redundancy. Code that operates on interfaces rather than concrete types is inherently reusable and can be applied in various contexts, enhancing the modular nature of the codebase. Enabling polymorphism in Go, where there is no traditional inheritance as seen in object-oriented languages, interfaces provide a way to achieve polymorphism. Multiple types can implement the same interface and still maintain their distinct implementations of the interface's methods, allowing methods that accept interface types as parameters to operate on a variety of actual concrete types, thus employing polymorphism. Standardization. Interfaces enforce a level of standardization in code. When a set of types implements the same interface, it guarantees that they all adhere to the same contract of methods, which means that they can be used interchangeably in any context that requires that interface. This standardization simplifies understanding the capabilities of different types without needing to study each type's detailed implementation. Let's see in practical how we implement the interface in Golang. Create one interface with name mammal using interface keyword. Here we are adding in each interface name its standard approach in Golang. Like mammal become mammaler, in mammaler interface we have one function speak and it will return string. We create a one structure in Golang using struct keyword. Now dog struct will implement the mammaler interface functionality, as dog also speak like bark. We added the dog after func keyword in closes bracket as we known as receiver. This way only dog type of object or mammaler reference variable able to call that method speak. Let's execute the code and see the output as we created the object of dog type. As I gives my dog name is Pricky. After execute it's executed correctly and print bark as its return from speak function. Now let's change the implementation way. Now we create a one reference variable of mammaler type that holds the object of dog type as we implemented the speak method on dog struct dot. It can't access the name of the dog as we set during the creation of dog object. With the interface reference variable we just able to access the functionality. We can add getter and setter for setting the variables of struct. As we add one set method in interface and one get method. Set method takes one string value and get method returns a string value. We need to implement those methods in dog struct through invoke the set method. It's setting the name of dog object. But if you notice a bit, I use asterisk symbol in receiver. There is one reason, because if I not use that, it will not reflect the original data. No, we can use those interface methods with n number of structures, as mammals have larger number of subcategories like cat. Let's create a cat struct, and same like dog, we have one element name in cat struct. In main function we are creating one object obj as cat type, and later we are assign the object address to mammiller reference type, and through reference type m setting all the details of cat object. Let's run it through gorunmain.go. If you see it's running without any error, it's print the dog name is Perky, sound is bark. Also it's printing the cat details also, as we set the cat name is Kitty, cat sound is meow. Sometimes we are just adding connection method in interface. Later on we think about the implementation of the connection method as we know about the which kind of source we need to connect as DB or file. Thanks for watching and don't forget about the like, subscribe and comment.